Hello everyone, welcome to the Data Engineers Club, Sumit this side. Here comes yet another interesting big data mock interview. The person who would be taking this would be Ankur Bhattacharya and the one who would be attending this would be Koliseti Sashiram. Now let me talk little bit about Ankur. Ankur has around 9 years of industry experience with more than 7 years in big data world, right? And he has been working for KPMG Global Service. He is right now assistant manager there, working on very tech stack in big data technologies, right? His primary skill lies around Spark, AWS Cloud, Databricks, Kafka, Airflow, and many more technologies. He's a well-known person in big data world. Now, talking about Koliseti Sashiram, he is a big data consultant working in Cerebral Technologies with close to 3 years of experience, right? Now, he has been working on variety of technologies, including PySpark and many others. Now, before we start with this interview, I want to check that are you really enjoying this series? Do you feel this series is helping you out? Do mention in comments and make sure you keep liking the videos if you're enjoying it, because that will help us to be motivated and bring more videos, because we are spending time for the community, the person who is taking the interview and the one who is attending. There is a lot of effort involved. There is a lot of background work involved in terms of editing the videos, bringing it to you, and you should appreciate it by liking it, commenting on it, and supporting the initiative, right? Because that will keep us motivated. As this is a non-profit initiative, you have to keep us motivated because we are regular in our efforts and there is a lot of work going on, right? So do support the community, and if you really want to help, you can be one of the interviewer if you are taking interviews within your company, or you can attend the interviews in case if you are looking to attend the interviews, right? So this will help everyone out. Let's make this community big. Let's help the data engineering world, right? So with this, let's start with the interview.
Hi, Ankur. Good evening.
First of all, thanks for attending the session. And so I'd like to know about your current project, your all over expertise in the big data world, what kind of technologies you are already working in. So you can start here.
Thanks, Ankur, for opportunity, first of all. And then my name is Ram. I was working in a consultancy company where we work with data engineering tools. So I have a 2.5 years of experience. I have worked in 2 companies in these 2.5 years. One is TCS, another one is Several Technologies. So first I have worked with the on-premises system where I started my journey with the on-premises, Hadoop, Scoop, Hive, Spark, where we have used a cloud era for it. And then I have moved to this company where we are using modern tech stack here. And in this company, I have dealt with 2 domains, insurance domain, and also right now I was dealing with oil and gas, natural green energy domain. So first of all, when I worked in the DCS, it was a retail domain. Then here the insurance domain. In the insurance domain, I have worked with DBT, actually data build tool, which will be used for transformations. And then right now I was working with one company, which is one of the biggest green energy source company. And then here I have used the Databricks and then ADF. Based on the problem, we have to pick the tools, correct set of tools for it.
I would like to understand your current data engineering project. You can give me a brief overview how the project works, what is the data flow diagram, and what is the overall architecture, what kind of tools you are using, and what kind of problems you are solving.
Okay. So if I tell about my insurance domain, first, it was the first project where we get the data from the various sources. We get the data into Amazon S3 actually. From there, we take the data using Databricks. We use for the data ingestion, we use simple autoloader for it. In the Databricks, we have autoloader feature for that. So we take the data and then we put whatever data we get, we put as it is into our raw tables, which are bronze tables. And then we take it, we clean it, and also we transform it. We don't perform any business logics in this. We just filter, clean, and transform it and put into the silver tables. From here onwards, we take this data again, and then we perform business logics. We put into the gold layer tables. From here, we give, based on the business logics or the requirement, we perform aggregations, and then we give the insights to it. So we put our data to be ready to use in the gold layer. So we follow Medallion architecture for this whole project. This is my first project in this company. Right now, in the second project domain, it was a green energy domain where it has involved lots of one, but my responsibilities will be uh, I was participated in various modules in this project because it's a complex one. But my responsibilities will be five actually: moving data between the system, managing data warehouse, schedule, execute, monitor pipelines at the same time, serving data to the customers at the same time, data strategy for the company. When I say actually moving data between the system, it involves ETL and also ELT. So we take the raw data, we transform it, and we load it. For in this case, in the current project, right, we get data in three sources actually. One will be API, another one will be we get data from the MySQL actually, and also Oracle. Then the third one will be there is a third party the company has tied up. They will dump the data in the form of JSONs in the ADLS Gen2. Actually, it's a blob storage. We take it based on the scenario, actually, we can use ADF for the ingestion, or else we can directly use Azure Databricks for it. Suppose if a API is little bit complex, they don't want to share any credentials of it, or they don't want to make any private network for it. We can directly make the Databricks, and then we use a Python request, and then the API is pagination one. So we just take the data in the form of pages until the data becomes last data will become null, and then we take it, and whatever we have taken data, we try to put into the bronze tables. We don't do any transformation. It acts as a source of truth for us actually. Okay. Then whatever the fields we require, if suppose there is a column in the JSON, there is a one column array column, it have all the columns actually. Then we try to explore these values, and then from the JSON we explore every column, and then we put into silver tables. That will be the second. Then from here, then we try to perform the data transformation logics or whatever the business requirements. Then we put into gold layer. From there, it will be served to the dashboards. We don't use any other dashboard, data visualization tools, because Databricks have data visualization in the form of SQL warehouse. So we use SQL warehouse and the SQL editor for that, and then their dashboards will be created in the Databricks itself. So this is my moving data actually. When I say managing data warehouse means like here how the data will be stored in the under the hood storage actually. So it may be how the data will be partitioned or bucketed, or how the data will be stored in an optimized way. If there is any PI fields, security fields, how I have encrypted them, and then how I am ensuring whether data will not be leaked, that one. Then I have to schedule, whatever pipelines have been right, then I have to schedule, execute, and monitor them. And then based on that, I have to take the decisions. Then data strategy for the companies means how the data will be going to be used for them actually. And then serving data to the company is like I was working in the serving layer of this whole company module, where whatever the data we have collected, whatever the reports we generated, how I can give them to the customers. So it may be access control, or it may be the data will be in the form of files, or it may be through REST APIs, how they can access. In the Databricks, we can we have SQL warehouse. You hit the REST API, SQL warehouse REST API. They can then get the data. They have one portal. In that portal, they can download data sets. Have built something right where they can, when they click on the download button, it will take the data from the Databricks, and then it will be downloaded to the ADLS Gen2. So they can view that data sets.
Understood. Sorry for the interruption. Just wanted to understand one thing. What kind of business problem you are solving in your this project? What you are trying to achieve actually? Just give me a brief overview.
Yeah, it was about how their oil and gas and then their green energy resources will be. We just monitor their vessels. Vessels may be their fuel tanks, or it may be whatever they are storing gas ones. So what will be the values at the start of the day, end of the day, or what was the consumption, which region is taking the more, and then what will be the this month, how they have consumed it. So that based on that, next month we can predict it, and then which customer they are having more billable there. And then we have control their logistics also, how they are. And then there is one more part where they get the IoT sensor data, but I was not part of that module. Where they install the sensors, they will get their data, real-time data. Based on that, they will take them.
And you said that you're also involved in the data security, and so how that works, what kind of work you have done to secure your data?
Okay, for this data security, we have built one framework, which is entitlement framework. What? In Databricks, there is a feature called row level masking, column level masking, actually. So if you want to showcase the value of a column, you can show that, or else you can show redacted value. So we have assigned some set of values. If it's a string, show redacted. If it's an integer, show 0 for it. Date, null, timestamp, null for this. So what this framework does is like, it will have a one form. If anyone fills that form with the table they want, whatever they want, they can, when they submit, there will be created one more view on top of the table. So it will be based on the case when statements. If user is part of the data team, they can see the table or not, then he can see that or else. For this, we have used encryption methods. We have used AES encrypt actually. For that, we have stored the keys in the Azure keyword. We use that with the DB utils secret scope, so that we have linked our Azure keyword with the Databricks using DB utils secret scope, so that we can retrieve all the keys. So based on the domain, I mean, we have various domains in the same project. So we have various keys for it. Based on that, encryption will happen. If there is encryption happen, they can see the original value, or else they can see the redacted values for that.
Do you also use Unity Catalog for the role-based policy?
Yes.
Okay. Okay. Just trying to understand that what kind of latency or what kind of bottleneck have you ever experienced in terms of latency in your pipeline, and how do you resolve that if you experience any?
Yeah, recently when I was joined into the project, right? Actually, there is one pipeline which is already built, which is on the Databricks. It was very good at the starting of the data where they get the small amount of data, but once it is accumulated over the period of time, the data is become big, and then the processing will become very slow. So the results or the reports they want, they are getting very slow. So that's a bottleneck. First one I have solved in this project. So I have went through the project, I mean the pipeline further, where I have seen the cluster configurations. Based on the cluster configurations, have changed. Whenever I want to change any pipeline, I do two levels of changes. One is I check the cluster level configurations where I can do resource level changes. Second thing is code level changes. If someone has written the code in a not good manner, we can change it. So first, in the first level, resource level or configuration, where I have checked that the CPU cores and the memory is not in the good alignment. So the per CPU core memory is very low. So because of that, it was writing data to the disk actually. So spilling is happening. So we try to increase the CPU cores for the executors. At the same time, they are using the less number of nodes for it, and the executors will be less. So I have increased that. Then the third thing is like shuffle partitions. So because of during the processing, actually joins are there. So this to make these joins better way. So the shuffle has to be done in a best possible way. So we try to see how many shuffle partitions are there. By default, it will be 200. So suppose if I have more number of cores, I can utilize them, right? If I have 1,000 cores, and then 200 are only shuffle partitions, 800 are sitting idle. So I can leverage them. In case of shuffling, basically we get shuffling in window operations or joins or any aggregations actually for these, right? So I have observed them. Based on that, I have changed those. Suppose in a joins, if there is a smaller data set, I can, with joining with a larger set, I can do the broadcast actually there. Preferring shuffle has joined over a sort match. This is the second. And then there is one more thing in Databricks we have. We can set some properties, something like cost-based optimizer. We can set it enable true. Then joining reorder. If there are multiple joins happening on the same data frame with the different tables, if you have set join reorder equal to true, it will on the fly change the joining reorder. It will do in the best possible way among all the joins. That way. And then there is one more property which is we use Delta Lake as the file format.
What is the property name you have told which change the join strategy?
Join reorders. So delta.spark.join reorder enabled equal to.
But this is also if you enable the relative query execution AQV, this also does the same thing, right?
Yes, correct.
Then is there any difference between these two property AQV and whatever you're telling?
Actually, for these two, join reorder and adaptive query, right? So when we enable this, for these two, we have to first compute the analysis on that. there is something command analysis table, compute statistics for the columns. We can set the join columns for that so that we get the statistic. Based on these statistics, on the fly, it will select the best query plan. Adaptive query execution does that. But if we set join reorder at the first itself, so before AQ comes, it will try to use these statistics and change the join reorder, actually.
Suppose you have two large data set. One is 36 GB and one is 40 GB. So you won't be able to do broadcast because both of these tables are large in size. So what kind of join strategy will follow to have optimized pipeline?
Okay, so in case of two large data sets, we have no option. We have to go with the sort match, actually. So in this sort match, actually, as I've said already, if you do the joins on the columns which you have statistics, it will help a lot during the execution. So Databricks have this feature, adaptive query execution, right? So it will take leverage of all these statistics, does the things in the best way. And one more thing is like, if we have done the partitioning or bucketing, I mean, basically bucketing will not be possible in Databricks. We do Z ordering for it. So if we have partitioning or Z ordering on the joining columns, it will help a lot. So that it will do the pick the only folders which have these join columns. So this is
what is the difference between bucketing and the Z ordering?
So basically both will Z ordering is similar to the what we do in the bucketing in Spark actually. But the thing is like Z order have some limitations, something like you have to use 4 columns at max. We don't use more than that. And also in both bucketing and Z ordering, it will just take out how many number of rows you have and then divide that into. But in case of bucketing, you have to tell how many buckets you want. Suppose by cluster into 4 buckets, into 3 buckets, we have to define. But Z order will be taken by the Databricks under the hood actually.
Okay. So in your project for data ingestion, what kind of how we do the data ingestion in your project?
Okay, I have worked on 2 modules for the data ingestion here. One data ingestion module is like they get the data from the APIs, right? They use ADF for that. They have used their web service for that. So they created a link to service, then data set. So they take the data from it using a relative URL and base URL, and then they try to put it into the Azure Blob storage based on the one. Then from here onwards, they will take the raw data. This is one. And second thing is like taking data from the Oracle. This is also we have used the ADF only actually in this module again. And then third module one is like there is a third party API. They put the data in the one ADLS Azure Blob storage. We take it. So this is one. In the second module where they don't want to use any ADF, they want to cut off the cost actually. They are paying money for the Databricks. At the same time, they are paying for the ADF. So if there is any possibility, if a API is giving very less data, they try to use Python REST APIs to take the data from it using the request actually. And then they put here. So these 3 ADF I have used. And one more thing is like in the Databricks, I have directly used a request. And one more thing is like autoloader. So we have used autoloaders, which will figure out what is the new file and then take that file for the processing for the first time. Next time onwards, it will put that one in the checkpoint.
Suppose I do have a requirement. Suppose you have an on-premise database. You are getting some kind of transaction happening, like some insert happening, some update, some delete is happening. And your client wants to reflect this data in a dashboard, in a live dashboard basically. So your requirement will be first, you have to take that data in a live stream manner. Then you have to put those information in a data lake, maybe in Azure ADLS Gen2. Then probably some aggregation will happen and you have to process that data and you have to build a live dashboard. So what will be your thought process and how will you build this pipeline?
Okay, if the insertion updates happening on the Oracle directly, if there is a CDC feature enabled for that, change data capture, so that I can directly know which are changes happen.
How will you implement CDC and you will connect the on-prem DB to that? You can explain.
Yeah, okay. So if Oracle database is the or any MySQL actually, we have used the CDC feature enabled on that. Then we use a self-hosted integration runtime in the Databricks, in the ADF actually. We will connect this one with our ADF. So we take the whatever recent changes happened in it using CDC. We just have to find out inserts, post images, and also then what are the deletes happen. So based on this, we will take this data. We will try to use merge kind of operations in Databricks, where it supports if you have any updates done, so that if you can do update on the Databricks silver table also at the same time. So if there is any deletes in the merge right now, they are supporting source delete also. So if there is one row deleted in your source, you can delete in your silver table also. Once this is done in the silver table, it is directed to the dashboard. In my case, I try to use Databricks dashboards. In that, you just need to write a SQL query. Under the hood, it will be populate data to the dashboard.
Yes. What are the different kinds of triggers available in? Have you worked on using ADF triggers in your pipeline?
There are three kinds of triggers actually in ADF. One we have scheduled, tumbling, and then storage based. Basically, I have used storage based actually more. The reason is like we have to capture the file as soon as it gets it. The reason why we have picked it. Storage based event triggers like the moment the data come in the form of files in the blobs, we have to capture that using trigger file folder name and file name. Have to take the new file and then have to process it. This is one. And one more is scheduling and tumbling. So in case of schedule, you can put your scheduling for every minute, hour, or you can have a month, day wise, day in a week. But in terms of tumbling, where you have to select the slice of the for every 2 hours if you want this start time and end time. When it comes to tumbling window, we use that when we want to load the data. I mean, when we want to run the pipeline for the historic, actually, previous days. So at that time, we have used this tumbling.
Okay. You work in Spark, so obviously you know about the term lazy evolution. So can you explain that how lazy evolution helps Spark in optimization?
Okay, lazy evolution is a Spark strategy, to be honest. By delaying the execution of transformations until an action is triggered, so that we can optimize our execution plan. So, but it will allow Spark to optimize its sequence of operations. Suppose there is a transformation. The moment we apply any transformation, it doesn't get executed. Transformations are lazy. This will be added to our DAG in the backend, DAG and computation. When a driver requests for the data, at that time, these DAG will be evaluated so that these DAG will be evaluated. Suppose if we are taking a 1 GB, I mean, I was just taking as an example. We need a 1 GB file data. In that, we want to filter only one kind of column. So which are only 5 rows. Instead of loading all the data, if you, because of Spark lazy evaluation, when we apply transformation filter and then action, at that time action, it will be taken care. I mean, the job will be run so that we will load a very less data for this one.
Yeah. When you were talking about the Spark optimizations you have done in your projects, you mentioned that you configured the cluster. You found some problem happened in your executor in terms of the correct number that was not there. So you reconfigured. So suppose you have, 10,000 GB of data or 1,000 GB of data. How will we start the configuration? What will be the ideal number of? Obviously, this is not a strict number, but you should have some number for the starting point. So, what will be the ideal executor numbers? How will you calculate the executor memory? You can just explain the process.
Basically, how we calculate the executors will depends upon the partition size actually. So suppose in one of my project, it is 128 MB actually. So for this 128 MB, I just divide the whole data and divided by 128 MB, whatever the partitions is. I get the whole data, how much MB it is. Then based on the course actually, I have read this actually. When you are creating executors, there are two kind of strategies: thin executor and fat executor. But when I have read about both of them, then I have found like if your number of CPU cores are more than 5, you will see some HDFS throughput suffer. So the best possible way I want to start is like executor with 5 cores actually. So based on this, I will see the cluster configuration. So I start with executor core 5, actually 5 cores. Based on that, I will figure out how much memory each executor can do that. Then based on that, I will find the number of executors and then. So right now we are doing in Databricks. In Databricks, each worker node is one executor actually. But when I told about my on-premises system, right, there we have to do the using, I mean, we have to submit the jars and then do that. Where Spark will be static allocation mode or a dynamic allocation mode. Have to tell about executor cores, executor memory, ideal timeout, and then initial executors, max executors for that, and then min max of values of these ones. So this is how I start with my working. In most cases, we don't get correct number at the starting, but I'm sure like after 1 or 2 runs, we will figure out the best one. We can't able to figure out the correct number at the starting, but 1 or 2 trials we will get. Suppose we have gone through some configurations. If it sees like it's running very, very slow, then we can little bit increase and then change these things. but within 1 or 2 runs, we can easily figure out what was the correct configuration for it.
Okay. Let's move into some coding questions. I'll give you a Spark SQL problem. You have to, you can start this solving the problem with a data frame. If it is not that much feasible for you, then you can try doing by the Spark SQL as well. But I'll suggest that you start doing it by the data frame. I'll send this to in your chat. You can share your screen and start solving.
Okay, I'm sharing my screen.
Okay, so if you see here, it's a very simple one. You have 2-column revenue and date. So basically, I want the cumulative revenue for each date. If you see like 22nd May, there is 3,000. So date and total revenue, 22nd May 3,000, 23rd May will be the cumulative sum 8,000, and then going forward, you have to do for all the dates.
Okay.
All right. Yeah, now you can see, share your screen and start solving this.
You can see my screen, correct?
Yes, I can see.
Okay. Give me 1 minute. I just want to go through the question. Then I will tell my process of solving.
Okay.
Okay. Okay, Ankur. I will tell my approach for this. Then I will start my coding. Actually, this is how I want to tell. So if we have seen that we have a data month wise actually, and then date also. So if you want to cumulative response of month wise, actually, what we are going to do is I will just take a one window. Okay. So for each first before the window itself, I want to calculate the month of it. I will use a date part function. I will figure out the which month it is, so that I will have a month for it. Then I will run my window function on this month, and then order by date. Anyhow, the date will be there we have, so that we will have a order by date. So I will calculate my sum on this window, so that I will have a cumulative sum for this. So this is my approach for that.
Sure.
So if I have considered this one, I am just considering this data is in a CSV file or in any Parquet file.
You do not have to read that. Just think that it's a data frame already and it's revenue DF. You can start from there.
I was just giving that as a date DF. I was figuring out the month column from here actually, which month it is.
You're calling this data frame as data underscore DF, right?
Correct. Okay. So I just load my data into this date DF. If you want, I will write that. And then for the first thing I have to do is like I can use my month function to extract the month, or else I can use date part. Date part will tell us which I want to take. So I want to take month of this one, and then I will tell this is as a date, date column from this. So I will have the months from this. Example 3000, 22 May, and then I have the 5 there. So that I have a one column which is tells the month of it. Then based on that, I was just so I will have a window which will be based on the month, and then in its order by its date actually. So I will use this one.
Okay.
So that whatever window I have created, I will do that on that. Then I will calculate the sum of it actually. So sum will be based on the revenue. So that I will have something like 3022 May, right? Yeah, you have seen this, right? First there will be
Yes.
a date. Then at the end I will drop my month column. I don't require. When I was selecting the columns, I select only the sum column, whichever I have required. So I will just select my total revenue column and the date column so that I will get it. All my intention was like I have to take the partition. Partition will be on based on the month. Then calculate, take a sum of it. When I was doing a sum, just use a order by based on the date you have to calculate. Suppose there is in the May
But
there is a
this will give you the total revenue based on your month. So in 22nd May, and both of these 22nd May and 23rd May and 25th May, it will come as 30,000, 13,000. So if you see, it's a rolling sum. So it's a cumulative sum. First, 22nd May is 3,000. In 23rd May, the revenue was 5,000. So I am adding 5,000 into 3,000 and give the result is 8,000. In 25th May, the revenue is again 5,000. So it's 5,000 plus 5,000 plus 3,000. So total 13,000. So it's a cumulative sum.
yeah,
So you have to define a range here.
Okay.
So,
What I mean is like the rows between the unbounded preceding and the current row. That was a by default. That's why I have defined. I didn't define it actually. So I was taking the range as like unbounded preceding, and then take the current row. If I mean if I am at the 8,000, right? Not here 23rd May I have 5,000. So from 3,000 to 5,000 you have to take everything. It means current row means 5,000. So it will
okay.
take 8. When I go to the next one, it's a 5,000. So what I'm taking, take the unbounded preceding and the current row. So 3,000, 5,000, 5,000. So 13,000. So by default, it will rows between the unbounded preceding and current row, right? That's why I didn't define it, but we can do that one.
Correct. That is fine. No, I was just trying to understand. So you're saying there's the unbounded precedent and the current row is the default behavior of the sum function in the Databricks. So you have not defined this explicitly. Yeah. Okay.
Yes.
Send you a schema. You can name it as employee DF.
Okay.
And I want to know this specific use case. Calculate the difference between each employee salary and the average salary of their respective department. I'm sending you a screenshot of how the output should look like, and then you can have the output schema.
Okay.
So in your output schema, there will be ID, name, age, department, salary, all the input schema as well. Then average salary by department. So each department, what is the average salary, and difference by the salary of each employee with their average salary of the department. So it might be in positive, it might be negative as well.
Give me 1 second. I just go through the schema of it. Okay. So my intuition for this one solving is like we calculate the average salary for each department. Okay. Then we find out the difference between average salary and then the salary of an employee so that we will get the different salary. So this is my intuition. So the first part I will take is like data read, then find out the average salary for each one, each department I meant here. Then we find out the difference. Employee DF is the CF DF data frame we have taken. Okay. We can do this in two ways. One is through aggregations. One is window, actually. When I go through the aggregations, we will have the one table which will have one data frame which will have department and its average salary. Then
Okay.
where the department name will have serve as the key column. And then we have a original data frame. It's already have a department. We can do this one to find out to do a join and then do that. That is one. Or else window operations. Both will involve the shuffling because it's an aggregation plus join. Here it will be a window. So I will, which one I can do that one?
Anything, whatever it's coming to your mind first.
Yeah.
You can do that.
Average salary by department. So the output will be something like department. So here it will be something like, then what we are going to do, we can use this employee DF and then average department name. We will use their department as the key column. We can join them. So,
Okay.
then we will have the average salary column beside every row. Then we can directly subtract it. Because of these join, the department column will come 2 times. So it will lead to it will get a confusion which department column I have to print. So I was removing one of the average one department name, so that we will have only few columns.
Do you know why it happens in Spark, but normally in SQL Server or normal transactional database, when we join, this join column do not come twice in the output schema, but why it happens in the case of Spark?
Okay, when we do in SQL Server, all right, we do a alias for it first. The table name, suppose table A, I put a name for it, join table B. And then we are doing this one, right? The column names will get the table names dot column actually. Because of that, the confusion will not come whether it's the same column or not. But the moment we go into the Spark, it doesn't get the data frame name has a part of its column, so that we get this confusion. This is my one actually.
If you alias the data frame and then if you start the joining, then will it occur or will it not occur?
Sorry?
When if you just give a name for that data frame, and after that if you join it, then that confusion will happen or not? That ambiguity will still occur or not?
I mean, this is not the one you are talking about. I mean, here we have given the one, right? I'm sorry.
I was just it's okay, you continue.
Okay. So here the schema will be something like ID, name, age, and then department, salary. Now we get the new column, something called average salary department. So now we have to just do a difference between them. We can just take the join DF. We just produce a new column, something like join DF dot with column. And then since this is a new column, right, we can give the name of it. 1 second. Diff salary by department. So I just give it name, diff salary. So that I want to calculate it, the difference between that.
Okay.
So that we will have all the columns. Then anyhow, our final data frame needs all columns actually.
Mm-hmm.
So we need, so that's why I'm not selecting any particular column, which column we need actually for it. Okay.
So that's all from my end. Ram, do you have any questions or something?
From my end, like I just want to know about the feedback. Is there any areas where I have to improve?
Yeah, I'll send the feedback. Yeah. Thanks for attending the session, Ram.
Yeah, thanks, Uncle. Thanks for connecting. I mean, glad to meet you.
Yeah, thank you.
Thank you. Have a good day.
Have a good day.